All right, welcome back, everyone. We are excited to have our next presentation lined up for you. We're here at SpringOne on the beginner-friendly track. I'm Bob Brinley with you all day. I did a little wardrobe change for you just to get my inner Cher or inner Barbara Streisand out. Still representing Spring, of course, because that's what we're here for, all things Spring. And we want to thank you again for joining us. And let's go on to our next presentation. Coming with us with Batching for the Modern Enterprise is the one and the only Michael Minella. Take it away, Mike.
Thanks, Bob. Let me go ahead and share my screen. Now let's get started. I want to start off with a thank you. I realize that right now the world is crazy with the global pandemic and all kinds of other things going on. And I just want to take a minute and say thank you. Thank you for taking a few minutes out of your day, your quite frankly crazy life that we're considering this new normal, and spending it with us. So I hope over the next hour or so you can get something useful. If not, there are other tracks, but please stay here for mine. But yeah, hopefully you're enjoying the conference and it will continue. A little bit about myself. My name is Michael Minella. I'm the co-lead of Spring Batch. I'm the founder and lead of Spring Cloud Task. I also do a whole bunch of other stuff, none of which you probably care about. These are the ways of getting a hold of me. So I'm available via 3 different Twitter accounts. So the first one is my personal account. The second one is obviously the account for the Spring Batch project. And the third one is for a podcast that I'm on called Off Heap. Follow and if you want to get a hold of me, these are the best ways to get a hold of me. I do have a book out. It's called The Definitive Guide to Spring Batch with a foreword by the good Dr. Dave Sire. So please, if any of this sounds interesting to you, check it out. It's available where good tech books are sold. I'm also on a podcast called Off Heap or JavaOffHeap.com. This is a pundit podcast, so it is a handful of guys hanging out normally at a bar, but because of COVID, we're doing it remote. We talk about what's the latest and greatest of happenings in the JVM and IT industry in general. So if you want to hear a group of people just having a casual chats about what's going on in the ecosystem, I encourage you to check that out. So I'm really excited. You've chosen to spend your next hour listening to the most exciting talk at all of SpringOne. We're going to spend the next hour talking about batch processing. I mean, we've only been hearing for the past, 30-ish years that batch is dead or batch is dying. Replace your batch systems with new stuff. And yet, even the Cloud Native Computing Foundation, when they wrote their serverless white paper, even they called out batch jobs or scheduled tasks as a targeted workload for that kind of runtime. Because we're seeing as workloads move from traditional infrastructure to the cloud, batch jobs are following. So what are we going to talk about today? We're going to cover two things. First of all, we're going to talk about what is batch processing. Let's kind of understand what is the workload we're describing. What are the problems we're talking about before we dig into bits and bytes. Then we'll get into actual Spring Batch. That'll be the framework that we're going to be talking about today. So what is batch processing? I define it as the following. Batch processing is defined as the processing of a finite amount of data without interaction or interruption. Let's break this down a little bit. First of all, a finite amount of data. In order to do batch processing, you need a batch of something, right? Batch processes are finite. They need to have an expected end. And so in order for you to have a batch process, you need to have a finite amount of data. You're not going to use Spring Batch or any other batch framework to process, let's say, never-ending streams of data. Without interaction or interruption. This is the one that I feel that's actually even more important, or the bigger distinguisher between between batch processing and other workloads. When you think of other workloads, let's say whether they be web applications, functions running on a FAS, message-based microservices, all of them have one thing in common, which is they all depend on external stimulus. So let's take a web application, for example. When you build your web app, you deploy it onto your servers or the cloud or whatever, you get it running and it sits. If nobody sends a request, it sits there, right? It sits and waits for an incoming request. Then it does the processing, it does its work, returns a response, and then it sits. So if your application isn't very busy, obviously you're essentially wasting infrastructure. Hopefully you're not. Hopefully your applications are busy and doing great work. Batch is different though. Batch, you get all the data together in at the start, and then you say go. And the batch process does all this work, and then it shuts down, leaving all that infrastructure open for you. It really, one of the main drivers for this processing model is the efficiency of it. You get to use only the processing you need when you need it, freeing up those capabilities for other things at different times. Batch processing goes back to the dawn of computing. The ENAC was essentially a big batch processing machine, and that hasn't changed to today. Even today, we see batch processing moving to the cloud, whether it be Cloud Foundry, Kubernetes, et cetera. So with the kind of general understanding of what batch processing is in mind, let's dig into Spring Batch. So Spring Batch is obviously the batch processing framework within the Spring portfolio. It's extremely popular. In fact, you could argue that is kind of the de facto standard for batch processing on the JVM. It was started out of a partnership between Accenture and SpringSource. Accenture obviously was doing a lot of mainframe transformations and had a lot of mainframe experience. And so the good Dr. Sire was the founder of the project. Him and other colleagues at Accenture built the initial versions of Spring Batch in collaboration with SpringSource. Spring Batch went 1.0 in March of 2008, so 2008, 12 years ago. And since then, has been used in every vertical you can think of: entertainment, government, finance, retail, IoT, literally any vertical you can think of. Batch processing with Spring Batch has been used. Spring Batch even served as the inspiration for what is considered the Java standard for batch, JSR 352. On the left is the specification document for JSR 352. On the right is Spring Batch's documentation. When it comes to the domain of batch, so the main components of batch processing and how they interact, they're exactly the same. I'm going to be talking about a lot of different terms that, if you're not familiar with batch processing, may be new to you. So let me spend a few minutes kind of defining what those mean. Let's start off with a job. So I mentioned a minute ago that with batch processing, you get all your data together and then you say go to some kind of process, right? The job is that process. That is the thing you're going to kick off, and it's going to run from start to finish. A job can be made up of multiple steps. Each step is an independent processing unit that can be run in sequence, in parallel, in orchestrated, really however you want within a job. There are multiple kinds of steps. The two typical ones you'll see with Spring Batch are a tasklet-based step and a chunk-based step. A tasklet-based step is a step that you have an interface called tasklet, and you implement that interface. Spring Batch will then run that for you within the scope of a transaction, either once or in a loop until you say otherwise. So it's kind of your roll your own step, if you will. A chunk-based step is really the idea of processing a number of items. So here, we're looping over something. We could be looping over records in a database. We could be looping over records in a file, something along those lines. When we talk about chunk-based steps, one of the important things to consider is an item. An item is that individual thing you're looping over. So it could be, like I said, records in a database. It could be records in a file. There's a bit of an art to defining what the item for your batch process is. Think of a banking example. You could have the transaction record as an item. You could have the account as an item. You could have a customer as an item that has multiple accounts and multiple transactions. It really depends on how you're processing and what that processing needs in order to make that happen. Now, Spring Batch clumps these items together into chunks. Let's say I've got 1 million items to process or 1 million records. Doing those all in a single transaction probably isn't the best architectural decision to do. So we break those up into chunks. So let's say I've got 1 million records. I may process 1 through 1,000 in one chunk, 1,001 to 2,000 in another chunk, 2,001 to 3,000 in another chunk. For each chunk, we start a transaction, process the chunk, and commit the transaction. Then we start another transaction, process another chunk, and commit the transaction. And that repeats over and over until all the data is exhausted. This is what a Spring Batch job might look like. So this is kind of the flow we would expect to see. So we've got 3 steps, step 1, step 2, and step 3. Each one of these steps has up to 3 components. One of them is optional. The item reader, the processor, and the writer. So the item reader, it provides the input for this step. So you've got a flat file item reader, you got a JDBC one, etc. The item processor is where you apply essentially your business logic. So you're going to make transformations, you're going to do enrichments, etc. The item writer is responsible for persisting the data. So it's going to generate the output. So write to a database, write to a file, etc. The item processor in each one of these steps is an optional component for a chunk-based step. Now with this flow, these are 3 sequential steps. So you're going to start step 1, it's going to start, run, and finish. Then step 2 will start, run, and finish. And then step 3 will start, run, and finish. Within a chunk-based step, the interaction between those 3 components looks something like this. So the step is going to call the item reader. It has a single method called read. It's going to call that until the chunk is complete, typically a finite number. So going back to what I was saying before, let's say it calls it 1,000 times. So it's going to chunk up 1,000 items. It's then going to loop over that list of items, passing each one to the process method on the item processor, if there is one. Once that's done, it's going to take the results of all the item processor items and pass them all as a single call to the item writer. So item reader and item processor, item-based, item write, or the item writer is chunk-based. The reason we do that is because there are optimizations that we can make on the item writer side that we can't make on the other 2. Think of things like batch inserts on JDBC calls or bulk flushing to a file system. In order to run a Spring Batch job, you need some infrastructure. So you need some things to manage the statefulness of a batch job. You need to handle the orchestration of steps and whatnot. And this is kind of how that lays out. So it all starts off with the job launcher. The job launcher is responsible for basically figuring out the job parameters to pass to the job and then launch the job. When the job launcher launches the job, it's going to report to the job repository, hey, I've launched a job. The job repository is essentially a data store that stores the state of your job. In our cases, it's going to be a relational database that is stored where you can keep track of what jobs have run, what steps have run, skips, reads, all that kind of stuff. We'll get into that in more detail in a bit. So the job launcher tells the job repository, I'm launching this job with these job parameters. The job then reports to the job repository, I'm running and I'm going to launch this step. It could be step A, step B, step C, 3, and so forth. The step is going to report to the job repository, I've read this many items. I've written this many items. This exception happened, those kinds of things. All those are available for you after the job ran via the job repository. Within the job repository, we have the concepts of job instances and job executions. And so a job instance is a logical representation of your run. Let's say you've got a Spring Batch application that's run once a night every day of the week. So you got a run for Monday, a run for Tuesday, a run for Wednesday, and so forth. And the job parameter you pass in is the date. So what is the date for that run? The job instance is identified by the job name and that parameter passed in. So you'll have one job instance for each day, each logical run of the job. Every time you launch the job, you will also get a job execution. The job execution is the physical run of the job. A job instance can only be run once to completion. The job execution is how we keep track of all those runs until it's been completed. You may only have one job execution. If the job was started and it ran, great, you have one execution. If you have to restart your job, you'll get multiple job executions linked together by that job instance. Each job execution will have one or more step executions based on how many steps that job execution runs. All right, that's enough of me blabbing for a minute. Let's go ahead and actually take a look at some code. And it is basically the law of computer science that we start off with a hello world job. So we're going to go ahead and start off and do that. So here I am in my IDE. I've got a basic Spring Boot application. If you're familiar with Spring Boot, this should all look familiar to you. So you've got your main method, it bootstraps the application. I've got my Spring Boot application annotation. And then I've got this enable batch processing annotation. So this is going to handle all of that infrastructure I mentioned before with regards to what Spring Batch needs to run. So just dropping that annotation on your application, that's going to handle bootstrapping that infrastructure for you. Our Hello World application looks something like this. So I've got a configuration class. Spring Batch provides a number of builders for building various things in the framework. In this case, we've got a builder factory for building jobs and building steps. So I'm going to create a job bean. It's going to take one parameter. It's a step. I'm going to call this.jobBuilderFactory.get the name of the job. I've got this incrementer here. And so what this is going to do is, remember how I mentioned a job instance can only be run once to completion. I add this so that Spring Batch will automatically, every time I run my job, will automatically give me a unique set of parameters. That way I don't have to worry about changing a parameter in order to run it more than once. This will be more important when we look at error handling later. Then I have a single step, so I say start, and then the step I want to run, and then I call build. Then I've got down here a bean that's of type step. So here I call this.stepBuilderFactory.get step 1, and we're going to do a tasklet step. Now this could be a Lambda if you want. I'm just using the interface so you can see it better. But it's got a single method called execute that we implement here. I've got a simple system.out.println, and then it returns a repeat status. So a tasklet can do one of two things. It'll either, basically it will run until I return repeat status finished. The alternative is continuable. And if I return continuable, Spring Batch is like, okay, you want me to run that again. And it will keep doing that until you return finished. Let's go ahead and run this application. And there, so we can see Spring Boot, by default, I didn't have to do anything. Ran my job on startup with a run ID equals 1. So that is that extra unique parameter that the run ID incrementer added for me. It executed my step 1. It said hello to all of you amazing people. And then it ended. And you can see my job ended with those parameters with a status completed. Now, while that's cute, most of your batch jobs are not going to be a single step. So let's go ahead and take a look at one with multiple steps. There's a couple different options here. So first, we'll look at the one with the syntactic sugar for running them in sequence. So here I've got 3 steps instead of 1. So they're all configured the same. They all have a system.out.println that says what step they were executed. And here I do start step 1, and then I can do .next step 2, next step 3. And what Spring Batch will do is, assuming step 1 completed successfully, it'll run step 2. Once 2 is completed successfully, it'll run step 3. And so if we go ahead and run this one, we can see my multi-step job ran. It executed step 1, it executed step 2, and it executed step 3. Again, nice, but what if I want to have something more complicated with regards to how those steps are navigated? Spring Batch has you covered. So here I've got, again, 3 steps, and this time I've got each step is the same configuration as before. Here I've got the check on what the exit status of the Spring Batch step was, and based on that exit status, it will indicate to me what step to run. So I've got start a step 1. If it failed, so on failed, go to step 2. From step 1 on star, so anything else, go to step 3. Right now, this step will complete successfully. So let's go ahead and run it, and we should see step 1 and step 3 run. And so we can see step 1 ran and step 3 ran. Step 2 did not in this case. Now, if we really quickly make step 1 fail and run it again, now we will expect to see step 1 run and then step 2 run. So you can see step 1 ran, my exception was thrown, Spring Batch handles that. Step 1 ends, and then step 2 is run this time instead of step 3. Obviously, you can get a lot more complex with this stuff, but that kind of gives you an introductory into what specifically Spring Batch can do. Now, we talked about chunk-based steps earlier, right? So there are 4 main interfaces that go into that step. There's the item reader, the item processor, and the item writer. This is the interface for the item reader. So it's a simple interface. It's got a single method that is called read. It returns 1 item to be processed. It will continue returning 1 item until the input is exhausted, at which point it returns null. Out of the box, we have 19 different implementations of item readers with just about every type of I/O you can think of available. So you've got things like AMQP, Kafka, flat files, XML files, JDBC, and a number of different options, Hibernate, JPA. We've got you covered. The next interface is the item processor interface. So here, again, it's got a single method called process. It takes 1 item in and it returns an item. An important thing to remember about your item processors when you're implementing these is that they're expected to be item potent. So if you have an item processor and there are errors conditions within Spring Batch, which we'll get to in a bit, your item processor may be run more than once. So if you need to do some type of processing in here, make sure that it's okay to run that more than once. Out of the box, Spring Batch has 10 item processors. Most of these fall into 2 buckets, validation and adapting of some kind. So we're either going to provide validation mechanisms, whether it be bean validation or other validating mechanisms, or we help you adapt other things to the item processor interface. Most of the times, you're going to be writing your own item processors. The last main interface of the 3 that we mentioned before is the item writer. So here, you'll notice instead of taking a single item, it takes a list of items. Again, out of the box, Spring Batch has 18 different item writers. We've got Flatfile, Gemfire, Hibernate, Kafka, even email. So again, chances are if you need to write something, we've got you covered. Now, there's an important additional interface that you typically won't interact with very much, but it's important to know about. And that's the item stream interface. The item stream interface provides a life cycle to each one of these stateful components. It makes them stateful. When a step starts, the open method is called with what's called the execution context. That allows that component to reset the state from a previous execution. After each chunk is completed, we call the update method. That allows the component to persist what data it needs for restart to the job repository. And finally, there's the close method. The close method allows you to clean up any resources that you might have used that are no longer needed. The execution context is that piece that we pass in. It's essentially a map of key value pairs. The reason I didn't copy the interface here is because there's a whole collection of adapter or helper methods on it for things like type conversion. So get Boolean, get long, get et cetera, et cetera. So I didn't want to paste that whole thing here. Think of it as a map that stores the state for your job. Let's take a look at a chunk-based step. A little cleanup. I'm actually going to go ahead and blow away my database as well. Drop, create. And so here. So again, I've got my basic Spring Batch application. I'm tweaking things here slightly. If I were to do this via Spring Boot, build the Uber jar and run this from a command line, I would add batch.input equals /input.csv as my way of passing in what my input file is. I'm not doing that because I'm running all these from my IDE, so I'm cheating a little bit. But this is how you pass in a job parameter. For my file configuration, I've got to configure my reader, my processor, and my writer. So here I've got a flat file item reader. It is step scoped. What does step scope mean? Step scope essentially means to lazily initialize this component until it's within the step it's running. The idea here is specifically for job parameters, I can't build that on startup because I haven't run my job yet. So I haven't parsed the parameters yet. So we have to delay initialization of these components. So anytime you're dealing directly with job parameters, you'll be setting the scope of the component to be step scoped. So in this case, I'm building my flat file item reader. So I've got a resource that I'm going to read. That's the file I'm going to read. I have a name that I need to pass it. This is a delimited file, so it's a CSV. It's comma delimited. I provide a name for each one of the columns in there, and then I provide the target type item. And so by using these names in the target type, Spring Batch will call set first, set last, and set phone on my item type. If we take a quick look at the input, all it is there's 1,000 records in here, and it's got a first name, last name, and phone number. This job is going to uppercase the last name and then insert it into a database. So the flat file item reader will handle the reading of the file. The item processor will handle the uppercasing. So here I've got an implementation of my item processor, the process method. You'll notice I'm returning a new instance of item. So that way my item processor is idempotent. Here I'm passing in get first, get last to uppercase, and then phone number. So it uppercases that last name. Then I've got my item writer. Here I'm using the JDBC batch item writer. So here I provided a data source, the SQL for the insert that I need to do. I specify that this is going to be bean mapped. So by doing this, Spring Batch is going to call get first to populate that field, get last to populate that field, and get phone to populate that field. And then I call build. My job is exactly the same as before. In my step, instead of saying .tasklet here, I say .chunk with my chunk size. So I've got 1,000 records in my file, so I set the chunk size to 100. That means it will process 100 records per transaction. Then I specify my reader, processor, and writer, and I call build. This is the item that we're actually passing around. So it's got 3 strings for last and phone, the getters and setters, and then 2 constructors. So let's go ahead and run this. You saw before I deleted and created my database, so nothing up my sleeve. And you can see my job ran, it completed. And if we go now over here, you can see I've got 1,000 rows in it with first name, last name is capitalized, and the phone number. The demo gods have smiled upon me. So I don't know about you. I'm sure you write perfect code every time. I don't. So because of that, error handling within a framework is really important to me. Within Spring Batch, there's a whole collection of different ways of handling errors. But we're going to focus today on 3 of them, or talk about 3 of them. The first one is restart. So if your job is processing, an exception is thrown, the first option is it just stops, it fails. The nice thing about Spring Batch is when you restart it, assuming you're using stateful components and follow their rules, it will restart where it left off. No additional code needed. The second option is to skip it. So let's say you've got a file, and let's say, occasionally you'll get a record that is bad to parse. You can handle them in the morning when you get in, so you can just skip those exceptions. We allow you to do that. You can configure exceptions to skip, as well as how many to skip. The reason we make you configure the number of skips to handle skipping is because there's a difference between a handful of bad records in a file and having a corrupt file. I'm using file as an example, but these apply to all inputs. There's a difference between 1 or 2 records being bad or having an entire, let's say, corrupt file. And we want you to be able to determine what the difference is. So we ask you to configure a maximum skip count on it as well. The last option is retry. So let's say you've got an exception when you call a REST API. Let's say it's flaky. It's sometimes it's down, so I need to try again. Usually it'll come right back, so the next attempt, not a problem. You can configure exceptions to be retryable, and so Spring Batch will retry that up to a configured max, so that it gives your batch application the opportunity to recover intelligently on its own. Let's go ahead and take a look at these different examples. Go ahead and blow away my database again. There's nothing on my sleeve. And so let's start off. Again, I get my same Spring Boot application. We'll start off with restart. So restart, this is the same batch application that we just ran for the chunking based one. The only difference is I've got some invalid input. So on line 536 of this file, I've got a entry that is too big to fit into the database column. The database column is 50 characters wide, and this is beyond that. So this will throw an exception. We actually don't need to do anything to our job. This is configured the exact same way it was before. That's the nice thing about Spring Batch is so when we go ahead and run this, so we'll go ahead and run it. Uh-oh. Data truncated, data too long, column first at row 1. That's a problem. So our job failed. So we can see job, restart job, executed with these parameters with the following status, failed. So now let's go ahead and take a look at our job repository. So select star from batch job instance. So you can see we've got one job instance and we have one job execution. Now the job execution record, I apologize for the view on this, but you can see it's got start time, end time, all those kinds of things. The batch status, the exit status, and then it actually stores the exception that caused the problem. So when you come in on the following morning, you can take a look and say, oh, okay, let me go look at the file and figure things out. Now to run this again, so that let me actually check one other thing, which is our actual data, right? We want to see where it left off. So I've got 500 rows out of the 1,000 rows actually made it into the database. What happened was Spring Batch processed up to 537. 537 failed, obviously. So it rolled back to the last known good state. So now when we restart, it should pick up where it left off once we fix the file. Now, I mentioned before that run ID incrementer, every time you run the job, it'll give you a new one. We don't want that to happen this time. We want to restart the old one. So all we need to do is pass in the old one, and Spring Batch will take care of that for you. So that's the logic we need to restart. Now the only thing we need to do is we actually need to fix the file. So we'll do Josh, for example. Go ahead and run that again. And so now if we run it, our job completed with the status of complete. We now have 1,000 records in our database as we expect, as well as we can see we still have one job instance. So we had one logical run. We now have 2 job executions. So we had 2 physical runs. The first one ended with the failed status we looked at before. The second one is marked as completed. So that's restartability. So now let's take a look at skipping. So if we go over here and we remove this one from our context and we come over here. Oops. To enable skipping, we do need to add a little bit of configuration. The reader, processor, and writer, those are all the same. The job is the same. Nothing to change here. However, on the step, we need to add a couple extra lines. First, we need to call .fault tolerant. This is what adds in that extra error handling capabilities. So skip, retry, all of these are handled once you specify that your step is fault tolerant. And in this case, I'm just going to skip exceptions in general. You can get more specific if you want. You can list multiple, you can list individuals, it's all up to you. In this case, demoware, so do as I say, not as I do. I'm just going to skip all exceptions. And I'm going to set the skip limit to 5. Our file only has 1 bad record in it, so if I got more than 5, I know there's something wrong with my file. And call build. That's really all I need to do. So now if I go ahead and run my job, what I'm expecting to happen is the job will run, it'll run successfully. However, I will only have 999 records in my database. The reason for that is it will have skipped one. So if we go to select start batch, oops, I forgot to delete them, but you get the idea. So now I've got 1,999. I forgot to delete them last time. But so you can see that it skipped that one record and processed them all again. Processed all the other ones. One other thing we can take a look at is in the job repository, there's that step execution. So here I've got 3 rows because we've run 3 steps. We ran that first step with the on the restart. We ran the second step on the restart. The third one's the more interesting one though. So this is the one for the last one. So you can see it records the status. So exit status and batch status. This is the number of commits, the number of items read, the number of items written, the number of items that were skipped during the write. So we have 1 that was skipped. And we had 2 rollbacks. Why 2 rollbacks? We only skipped 1 item. The reason we have two rollbacks is the way skipping works within Spring Batch. So we had an error in the write segment. I pass in the entire chunk into my item writer. How do I know which one was the one that caused the problem? I don't. So what happens is I first pass in the entire chunk. It tries, it fails. I roll back the transaction. That's rollback number 1. Now I set the commit count to 1, and I'm going to try each item one at a time until I get the bad record. I get the bad record. I'm going to roll that back and then continue on and then set the transaction back up to 100 and continue on. So that's where those 2 rollbacks come from. The first one is the big one. The second one is for the individual item that was the actual problem. So that's error handling. There's a whole laundry list of other features within Spring Batch that I would love to be able to go through. But to be honest, some of these I literally have entire talks on, so we don't have time. One of these is listeners. So listeners are the ability to inject logic into different spots of your application. So if you've got a batch job, you've got the job execution listener that allows you to run logic at the start of a job or the end of a job. We've got the step execution listener that allows you to inject logic at the start of the step or the end of a step. We've got the chunk listener, the skip listener, the read listener, write listener, processor listener. The list goes on and on. You can inject logic into just about any point of a Spring Batch application you can think of. We also have a number of different ways of scaling batch applications. One of the reasons you run batch applications as opposed to other workloads is for the efficiency. So you're typically running a lot more data through a batch application than you will be through other applications. Your web app is handling 1 request at a time. Yeah, it probably handles a bunch in parallel, but the number of requests a day or a second is probably nothing compared to what a batch application is going to process. And so to be able to handle the volume that a batch application typically needs, we have a variety of different scaling capabilities based on your use case. The 5 options are, first of all, multi-threaded steps. So we talked about chunk-based steps. Chunk-based steps are you process your chunks in sequence. If you add in a task executor, we can launch chunks in parallel. So you can be processing multiple chunks in parallel. We also have the ability to run parallel steps. Parallel steps is where I've got 2 independent steps that I can run without any type of interaction between the 2. So I would run them in parallel via threads. There's the async item processor and async item writer. Here, where the item processor is the bottleneck, I can run that call in a different thread via future, and then I pass in all of the chunk of futures to the async item writer. The async item writer will unwrap each one of these futures and then pass those results to the underlying item writer. We've got partitioning. So in Spring Batch, you can partition workloads and have a manager-worker relationship work that out. You can do partitioning in 2 ways. You can do it within the JVM using threads, or you can do it externally via either messaging middleware, or Spring Cloud Task allows you to launch these workers dynamically on a platform. Finally, we've got remote chunking. So partitioning, the manager sends metadata to each worker and says, you handle that for me. Remote chunking, the manager reads the data and sends it out over messaging middleware to each one of the workers to process and persist locally. Remote chunking is a lot more I/O intensive than partitioning, so it's typically only used when processing is the bottleneck, whereas partitioning, you're typically looking to optimize on the I/O perspective. I do a whole talk with Mahmoud, the other lead of Spring Batch, on these 5 capabilities. You can find it on YouTube here. The last consideration around batch processing is orchestration. So I've got a batch job, or I've got multiple batch jobs. I've got one that depends on another. There's dependencies between them. How do I manage that? So there's a couple of different tools within the Spring portfolio to manage that. First, we've got Spring Cloud Task. Spring Cloud Task is going to enable you to run these on a cloud platform natively. So that's going to handle things like persisting things that are native to the platform, like what run ID at the platform level was involved in running that batch job. It's also going to give you batch capabilities for things like running those partition workers as tasks or jobs on your platform. So you get dynamic scalability of your batch jobs where you can launch workers, they run and shut back down when you need them. Coming up in the next version of Spring Cloud Task, which will be coming out later this year, we also have a single step batch job starter. So earlier we did a file to JDBC batch job. We read in a file, we sent it to JDBC. Spring Cloud Task, with this new starter, you won't have to write that code. You'll be able to configure that entire job just via properties. Spring Cloud Dataflow is the other piece with regards to orchestration. That's what Dataflow does. Dataflow orchestrates microservices, whether they be streaming applications dealing with messaging middleware, or via tasks being ephemeral microservices. If you want to hear about Dataflow, I highly recommend tomorrow checking out the Walking Through Spring Cloud Dataflow talk being given by Glenn and Elia. They're going to walk through the entire Dataflow system, streaming tasks, and give you an idea of what its capabilities can be. I also recommend, if this talk has been interesting to you, to check out literally in the next slot over in the intermediate or advanced Spring track, Mahmoud's talk on what's new in Spring Batch. He'll be covering the new and cool things we've got coming out in Spring Batch 4.3. And with that, I want to say thank you. Thank you for your time, and I'll see you in Slack. Hopefully Bob's tweeting about the talk.
Hey, we're live. That happened. Michael, thank you so much. I was actually literally on my Twitter feed trying to upload my fur baby. Lars over in the Netherlands had posted, hey, put your fur baby up on Twitter. So I was going through my phone trying to get my picture of my dog sleeping as we're SpringOne in here. So thank you all again for watching. Michael, thank you so much for that wonderful presentation. If you have any questions for him, head on over to the Spring Slack channel and check out the Beginner Spring sub-channel, and they'll have lots more information so you can talk to Michael if you have any more questions with him. We have our next presenter getting lined up. Will be about 15 minutes until that happens. I think it's 5 minutes past the hour is when Deshaun Carter comes on. I'm excited. He's warming up. I see him. He's doing the stretches. He's getting limber. And I can't wait for this to happen. He's one of my favorites, everybody. So we'll see you in about 15 minutes. Thank you.